Okay, thank you very much for joining. So in today's session, we're going to look into the design of our database system. So what we've done in our previous tutorial, we've looked into data, type of data, and the purpose of them, and how to implement them. And also we looked into explaining different type of databases. So we looked at SQL and non-SQL, such as structured and unstructured databases. We looked into explaining what was the difference between entity and attributes and the different type of relationships. Also, we explained the normalization and functional processes, and we now also ended the session by looking into database administration. So what we cover in today's session, we're now going to look into the design of relational database to meet a specific design brief. So we'll be presented with a scenario, and this pretty much going to align with the requirement from our assignment brief. So we have 3 mandatory learning outcomes and 1 merit and 1 distinction activity. So let's now get into our presentation. Okay, as mentioned, today we're now going to cover the designing side of our database. So we're now going to look into several stages which are going to be involved, and each of these stages will now have to ensure that our database will meet the needs of our users, function efficiency, and maintain data integrity and security. So what are the stages required for our design? We now required is pretty much going to need a requirement analysis. So what's the purpose of this analysis? We're now going to gather useful data required from our end users in order for us to deliver our database. And the activity that we're going to do, we're going to be conducting interviews, surveys, and workshop with our stakeholders to identify the data and the information that we need for our database. Also, we will need conceptual design, which we introduced in our previous tutorial, where it is used to create high-level data model, and is going to describe the main entities and attributes and relationship. Logical design. The purpose of having a logical design is to translate the conceptual design into logical model, which can now be implemented in a specific database management system. Physical design, we're now simply going to create a physical implementation of our database, where is now going to be optimizing storage and performance. Implementation, where we're going to execute the actual database on a physical design. Also, it is important to conduct testing and validating processes, which allows us to ensure that our database meets the requirement and function correctly. Deployment and maintenance. So once we deploy our database into our production environment, we have to now ensure that it's an ongoing maintenance. So we also have an example. We're now going to look into designing a student enrollment system. So for this database, we now have our entities such as students, courses, and enrollment, and each of them will now have their own attributes to which we now assign for our schema. Relationships. So how do we create our relationship? We need to understand if it is one-to-one, one-to-many, or many-to-many relationship. So we can see that a student can enroll in multiple courses, which means this is a one-to-many. And the course can have multiple students, which is a many-to-many relationship, or many-to-one relationship. Conceptual design. So ERD diagrams are now realized with a software called draw.io, which is very useful for creating these visual databases. And there are plenty other of online softwares which, by just creating a schema, just by creating the design, it automatically converts our design into a schema for us, which is very, very useful. Logical design. We have an example here where we now have our student ID, which is now going to be our primary key, and he has his attributes such as name, date of birth, address, so on. And this happens even for courses and enrollment. Normalization, again, we're now going to ensure that our table are in a 3 normal form by eliminating the redundancy and ensuring that dependency of our primary key. Physical design. We're now going to have a storage structure where we will now have indexing on student ID, course ID, and enrollment ID. This will now allow us to speed up any sort of query. So it is important to have the ability to use a CRUD statement, create, retrieve, update, and delete. So we now have the ability to, with SQL, we can now create table, student ID, where we now insert our primary key. We now assign values to, we have now assigned value for our name, which is going to be a character of 100, date of birth, and address again will be character. Same thing, we're now creating a table for courses and enrollment. Testing again, as we already said, it is very important, which allows us to insert operations to ensure that we have data integrity. We can also have queries to verify relationship and the data retrieval. And also we're going to be performing testing on the loads. Deployment allows us to migrate in our database into our production environment. Setting up monitoring, audit and maintenance schedule. Regular, and also we can now have regular backups and updates. Here is a summary of what we've covered so far. Okay, learning outcome 1. Now have to look into designing a relational database to meet specific client brief. So we all know that it is essential to understand the fundamental of relational database design, which we're now going to be including the difference between logical and physical design. So again, we've been given a scenario where in our scenario, we have to design a relational database for a library management system. So the system should manage books, members, and loan, tracking which books have been loaned and which member are due dates. So once we have been given this scenario, we need to now create our logical design. So we can now have draw.io, which allows us to now create our tables. And we can now have an initial sketch of how our library management system should be. So what are the steps that we have to follow? We need to be able to identify our entities. We have to identify what are going to be our primary keys, define our attributes. So what are the mandatory fields that need to be included, establish what is the relationship that they have between them. Once the relationship is established, we can now normalize to ensure that the database schema is normalized to reduce redundancy and improve data integrity. So here we have an example of how this is going to be. We have our entities, books, members, loan, and we have our attributes such as book ID, member ID, loan ID, and so on. So when it comes to relationship, we have an example here where a book can be loaned to multiple members over the time, one-to-many relationship between books and loan. And also a member can loan multiple books. So it's going to be a one-to-many relationship between members and the loans. Okay, so here's an example of code that we will now be presented when we creating our entity relationship diagram. Normalization, again, we covered this concept in our previous tutorial. We looked into our first normal form, second normal form, and third normal form. And we also defined the purpose of having them. Logical scheme, again, this is going to include, is going to highlight what are the primary keys for our entities. Physical design is now going to involve implementing our logical design using a specific database management system, which could be Oracle, MySQL, PostgreSQL, SQL, any sort of DBMS. Physical design, here are the steps that we need to require. We have to now create our initial table, define our data types, indexing, and now also partitioning. SQL implementation for physical design. Here is how our code is going to look like. And this are all the values that need to be added. So again, we have a summary of what we've looked into with the differences between our logical and our physical design. Now we're going to look into apply normalization to a series of documents in 3 normal form. So we know in that normalization, will now allow us to reduce redundancy. So this process is now going to involve several steps, often referred as normal form, and each will within a specific requirement. So now let's look into third normal form. So here we have an example where we have the following unnormalized data for the customer or the database. And here are the steps that we have to do, we have to follow. So with step 1, in a unnormalized form, the table will now is going to be containing repeating groups and redundancy. With step 2, with our first normal form, we're going to achieve, we're now going to achieve a first normal form. So we must ensure that the table has a primary key and all attributes contains only atomic values. Here's how our table will look once we've now converted into a first normal form. Step 3, we now have to achieve our second normal form, where we must now be in a first normal form, and all of our non-key attributes must be fully functionally dependent on our primary key. Okay, so we now identify partial dependencies, such as customer name, customer address, which are dependent only on order ID and not the entire composite key. Here's the code that we need for us to create our table. Also, we have to have the ability of modifying the order table to include only necessary foreign keys and attributes. It is also important for us to create a table for order detail to handle the many-to-many relationship between orders and products. Step 4, we now have our third normal form. So to achieve third normal form, we must be in our second normal form, and all the attributes must be functionally dependent on the primary key with no transitive dependencies. Here are the code that we now required, and here is the summary of how our tables are going to they'll look like once we have now normalized them and broken all the tables into smaller tables. So we have a customer table, order table, product table, and order details table. Then in outcome 3, we're now going to use a database documentation tool to document the design to meet a design brief. So we know that documentation is very important to ensure that we have clarity, consistency within our database for our developers and administrators and stakeholders. So documentation tools will now include entity relationship diagram, data flow diagrams, and data dictionary. So again, we've been given a scenario where we will now have to design a relational database for our library management system again. So the system should manage, as we know, books, members, loans, tracking which book are loaned to which member and when is the due date. So we spoke about ER diagrams, and we know that these are graphical representations. So we're now going to implement this ERD with our scenario. So we know our entities, our books, members, and loans, and we also know what our attributes are. And here is how the code will have to be pasted. Data flow diagrams. These are going to allow us to illustrate how data flows within a system, and it's going to be showing process, data store, data flow, and external entities. Data flow diagram for our library management system is going to include a level 0, which we have our context diagram, and this is going to be include our external entities such as users, admin. Then the process will now include, so in level 1 we have a processes, which is going to include adding, updating our books. Here is how our data flow diagram will look like. Here's the process that's required for our data flows. Then we have data dictionary. So a data dictionary is going to provide detailed information about the structure and attributes of our database element. So it's now going to include details such as data type, size, default values, constraints, and descriptions. Here's an example of a data dictionary for our library management system. And here's the summary of what we've covered so far. So now we're going to be present our design to our client using our suitable format. So we've now analyzed, gathered all the information we needed. We were able to now design our database and normalized our tables. So in this learning outcome, we have to have the ability to present what we've achieved so far. And this can be done through a PowerPoint presentation. So we're going to include an introduction, and our introduction has to briefly present what we've done to our client. So we will include our entity relationship diagram. We will explain what our ERD looks like, what the relationships are, and how they connect to each other. And then we're going to present our data flow diagram. So we will also have a visual representation of each level of our data flow diagram. Also, we're going to include data integrity. And again, we'll have our table summarizing our data integrity. Also, we'll have our slides explaining normalization and the 3 types of normal forms. And lastly, we'll have a final slide which we're going to summarize what we've done and how we have achieved our database. Now we've come to look into our merit criteria. So our merit criteria are we're now required to identify the opportunities to implement validation and verification to enhance integrity for our database. So we know that validation and verification are key process that will now enhance data integrity by ensuring that there are no data breaches, or we will now ensure that there's data correctness, consistency, and completeness. Also, when it comes to our database evaluation, we now have to look into performance evaluation, and this is simply a metrics and criteria that are now used to measure the performance and efficiency of a database. So here are the criteria. So we have to look into query response time, transaction through output, correct concurrency control, resource utilization, data load type, time, and scalability. Also, we can know that verification is now going to involve checking that our database design are implemented within the specification and standards required from our stakeholders. So we now have a schema verification. So this schema is just simply going to ensure that it is correctly defined and appropriate, and that we do have appropriate tables. Then it's important to look into constraint verification, which again is going to ensure that all constraints are correctly implemented. So validation, again, is going to check that all the data entered into the database is accurate. So what is this going to include? Input validation, such as, for example, this could be validating email address. Say if the user made mistake and they did not include @ or .com or whatever, our table has to have the ability to validate the effectiveness of the data that's been input by our user. Data type validation, again, ensuring that the data entered in each field matches the expected data type. So if we enter in a name, this shouldn't include numbers. So we have a range of validations where we're going to be ensuring that data values falls within acceptable range. Then we also have opportunities to implement validation and verification, such as using automated tools, which are going to now reduce time and costs when it comes to automate and verify schema of our databases. Improve validation. This allows us to perform validation, which we're now going to implement into our client side and our server side validation in application forms to ensure that all this data that has been entered by user is reliable and correct. indexing verification. We're now looking into indexing monitoring. So we're going now to regularly monitor and review the effectiveness of indexes to ensure that they are optimizing query performance. And here is a summary of what we've covered for our validation and verification methods. Okay, we've now come to our final learning outcome, which is our distinction task, which requires us to evaluate database design and how it meets the technical requirement of our assignment brief following a feedback. So we've now presented everything, and we now have to ensure that our work can be delivered to our stakeholders. So based on the feedback that we've been given, this has to now include examining performance evaluation, verifying that our database structure and the relationship are correct. And we also have to be validating data integrity and accuracy. So we have a design brief recap that's been given to us. So the design brief requires a relational database for a library management system to manage books, members, and loan, tracking which book are loaned to which member and the due date. So from the feedback received, we now have to focus on performance concern, data integrity, user interface validation. So perhaps our client are not very much happy with what they're seeing. We now have to ensure that our database can handle multiple users in a large volume of data efficiency, ensure that all data relationships and constraints are properly implemented, prevent data anomalies, and also ensure that all the data entered via our user interface is validated before being stored into our database. So the evaluation again, we're now going to look into performance evaluation, which we just explained. What are going to be this performance evaluation? We're now looking into query response time, action, transition through output, and concurrency control. Also, we have to look into resource utilization, data load time, and scalability. Verification, which is going to ensure that the data structure and relationships are now correctly implemented according to our initial design specification. So we need to look out for our schema verification, consistent verification, index verification. Validation. This will now look into the validation methods, such as input validation and data type validation. Also range validation and referential integrity validation. So here's a summary of what we've covered for our distinction activity. So this was everything that we needed to know. So I really want to suggest a useful website when it comes to creating databases. So not quite sure if you're familiar with W3 School.
Yeah, I think I've looked at them before for maybe in the last unit, not the last unit, the last subject I did, high statistics. I don't know why, but the URL looks familiar.
Yeah. So this is a very useful website where you can learn SQL. You can get started with basic commands, where you can create your very first tables. And at the end of all of it, there is always like a test, and you can achieve your SQL certification. Oh yeah, there's like a quiz.
Cool.
And then even a boot camp available. Yeah. Yeah, so W3 School is very, very useful. Everything you need to know is in here. Highly recommended.
Is it all free, or is it like a
Yeah.
subscription service? All free.
No, yeah, everything's free.
That's again, I'll definitely check out.
You can just sign up, create your account, and yeah, go through all the tutorials. Is there any question for today's session?
No, I think that's fine. Thank you. Let me just quickly grab the unit spec. So I remember looking at it and that's something like, oh, that was it. Yeah. No, not right now, but I will obviously drop you an email if I have to.
Yeah.
So I know it says in the unit, obviously focuses on database systems, and learners may be required to build the database that they design, but it's basically just all about laying it out, isn't it? More, I think that's all what we've been covering. It's more about doing a it's just late in the day, my brain's drawing blanks.
Oh, that's fine.
Drawing like a data diagram, also showing data entity sort of diagram more than like actually coding out in SQL. Is that right?
Do you mean the requirement from the assignment brief?
Yeah, from the assignment brief, because it says like, oh, obviously we're not necessarily building the database per se, like actually coding it out. It's just about sort of designing it and showing what it would look like. It could be like using data relationship diagrams more than like actually like setting out the SQL code. That website's still going to be very useful for learning SQL for sure.
Yeah.
But just clarifying that point. That it's more about just showing how it would be designed than actually hard coding it.
Yeah. I can like start the assignment discussion tutorial where we can go through those steps if you want.
Yeah.
Okay, let me just add this one in. You have the link, right?
I've got the link. Yeah, I'll see you in there.
Okay.
Thank you.
Okay, thank you.